Have you ever wondered what kinds of pollution affect fresh water? As our very own Thomas Villa once said, we never know the worth of water until the well is dry. Ladies and gentlemen, my name is Kaya Sio, an aspiring analytical chemist, and I'm here to present a compiled presentation by my colleagues and I, which is based on oily wastewater treatment using hollow fiber membrane. Pollution of fresh water has become severe because of tons of oily wastewater being disposed of into water bodies worldwide every year. Among all the advanced methods, membrane-based technology is the best method for oily wastewater fouling treatment due to its capacity in separating all droplets smaller than 20 micrometers. What are hollow fiber membranes? Hollow fiber membranes are membranes containing a semi-permeable barrier in the form of a hollow fiber. The fiber has pores on its surface that allow water molecules to pass through, but block larger contaminants which vary from their different sizes. Moving on to the methodology. Hollow fiber membranes are porous and have small sized pores that allow water molecules to pass through while blocking larger oil molecules. Here is a general overview process. Pre-treatment. Before using hollow fiber membrane, it is essential to remove any large particles or debris from water. This can be done through the process of sedimentation, coagulation, or filtration. The membrane setup. The hollow fiber membranes are typically arranged in a module, creating a network of tiny cubes. The contaminated water is passed through these hollow fibers. The filtration process. As the water passes through the hollow fiber membranes, the smaller the water molecules permeate through the membrane pores, the larger the oil molecules are retained and from a separate stream. Lastly, the separation of oil. The oil that is concentrated on the outside of the hollow fibers can be periodically removed by backwashing or black flushing the membrane molecules. This process helps to maintain the efficiency of the membrane and prevent clogging. Here is an example of how the whole process works. Moving on to the results and discussions. For the treatment of oily wastewater, the development of hollow fiber membrane technology is promising. Previous research has shown that the overcoming membrane flux reduction and permeable due to fouling is the main obstacle to establishing an outstanding membrane performance to treat oily wastewater. In earlier studies, the impact of weighing the hollow fiber membrane, packing density, fiber length, fiber looseness, and fiber diameter on the performance of the hollow fiber membrane was covered. The hollow fiber membrane filtration performance is improved by the lateral movement of fibers made by the low fiber packing density. In conclusion, discharge of oily wastewater leads to a serious environmental problems if released without sufficient treatment due to the toxicity of the hydrocarbon compounds. Numerous oil wastewater treatment approaches have been studied to achieve an eco-friendly method that would enhance treatment efficiency. In this regard, a comprehensive review has been conducted to provide a perspective regarding the practical aspect of the hollow fiber membrane technology for oily wastewater treatment. Studies do show that the optimizing operational parameters and membrane modification can significantly improve hollow fiber membrane performance in terms of maintaining the membrane flux and reducing fouling. With all this being said, we would like to acknowledge that our group would like to gratefully acknowledge the support from Ms. Masango for allowing us to conduct an interview with her based on our topic. We would also like to thank Prof. Mabuba for giving us the opportunity to do the research based on water quality analysis to acquire more knowledge. This presentation was not going to be a success without the group members who gave their utmost best on their research, reviewing information about the topic, and combining the slides to come up with this presentation. Thank you. I would like to also introduce the brains behind this presentation. Ms. Qsio, who did the introduction, Ms. Enhlongwane, who did the methodology, Ms. A. Sidima, who did the results and discussion, and lastly, Ms. T.P. Shivamp, who did the conclusion.